people seeing us right now or not? It's
Yeah,
like,
because whenever it started, right, it got delayed from the YouTube side, so it's a bit awkward.
yeah, there'll always be an 8-second delay, I think, between like what we say here in this dashboard and then what people actually see and how they respond. So yeah.
Yeah, even live chat as well. So sometimes we respond late, like we responded late. It's not because we don't see your message; it's the delay.
Yes, there is a delay. There is a lag time. Yeah, so we're really happy to have you back. For those of you who are joining us again
Rise, yeah.
for the third time, thanks, Dad. Your support. Oh, we're so touched.
There's no choice anyway.
Anyhow, well, we hope that everyone's doing well and having a great week. We know that for many of you in Malaysia, you're probably going quite stir crazy at home because there's really nothing much to do. Even though we can dine out, only 2 people per table in some restaurants, and the cases are still very high, so you don't really want to risk it. So if you're going stir crazy, come hang with us every Wednesday. If you know friends who are going stir crazy at home, just come and have fun here, because we might be studying, but take it as revision, or, just come here and just like chat, hang out with us. And by the way, a note on the chat, because we wanted to sort of like protect you guys from spammers that spam like inappropriate stuff. So if you want to like respond and connect with us, please hit subscribe, and then you'll be able to like interact with us and join in the fun. Yeah, so this is something that we thought through. Yeah, so we're not doing. Yeah, so if you don't like us at the end of it, you can just like, unsubscribe, and like, yeah, you always have a choice. So yeah, we're not doing this to get the subscribes, but we're just doing this to keep this community like protected. Yeah, although I did find a way, actually, Joe, to block spammers. Like during the live session itself, we can actually block them. Yeah, so yeah, maybe next week we'll open it up. But for today, if you guys want to interact with us, yeah, just hit subscribe, and yeah, and you can like go crazy on the chat. Yeah. Hey, Yvonne's on. Hi, Yvonne.
Hi.
Okay, so coming on, let's see. Okay, so yeah, so today we're gonna go through
our content today.
Yep. Yes, we are going to move into our content today. So for many of you, what we hear from the teachers in our school is that most students actually like forget or mix up the differences between distillation and fractional distillation. So it's one's fancier. I mean, it's got a fancier name, so therefore it's fancier. So today hopefully our ImagiNote will help you remember how to set it up and sort of help you separate the differences. So the ImagiNote is a separating technique to help you separate the differences. Get it?
Thomas says hello.
Hey, hi Thomas. Thanks for joining us. So yeah, so moving on. So what is ImagiNotes? You're gonna see. Actually, you're gonna see. But all we know is that. But what we do know is that this is the way of taking notes that we teach our kids. So Joe and I are teachers who hated studying because memorizing never worked for us. So even as a teacher, I try to do notes that actually help kids remember instead of having to memorize, because memorizing you'll forget. All right, and basically we apply this to our school. The teachers teach ways to remember that's actually like really, really fun and engaging. And so our kids actually don't study. We have fun instead learning. And this culminates in 1 out of 5 of our students getting straight A's. Because some of you, I realize like this is episode 3 already, some of you might be wondering, hey, go through all this trouble, we go through all this trouble, does it actually work? So yeah, based on results, and we've been doing this for the past 25 years, based on results, I'd say, yeah, it is working. 1 out of 5 students getting straight A's. So imagine this, if you have 5 friends, one of you have a high chance of getting straight A's. Yeah. So so again, we're not big on studying, but because of what we do, studying becomes like easy. Yeah, for a lot of our students. So and if you like what we're doing here and you want to pick up ideas on how to make your notes quirky, fun, and imaginative, Joe, what do they do?
Like and subscribe to our channel. Or you can just send the topic that you are facing struggle or you are facing struggle with, then send it to us. We'll see what we can do with it.
Yes, for those of you who are shy and you don't want to put things in public in case people laugh at you, DM us on our social media. We'll get right back to you. Yes. That is the shy person's option, DM. All right, so diving straight in. All right, so last week we actually did, if we look here, we actually did crystallization and evaporation. All right, so side by side, as you can see, the techniques are similar because crystallization does involve evaporation. However, as you can see, they are quite different. Yeah, okay, that makes sense. Okay, so again, last week we reminded you guys, if you want to, so same like fractional distillation and distillation, if you want to see the differences, our advice is for you to draw it side by side in your notebook somewhere, all right? So that it just makes it easier at a glance, that you can recall it really quickly, okay? So yeah, and I also remember last week we talked about, we taught you guys like how to remember dilute, concentrate, and saturate. The stuff that even Joe and I get confused about. Okay, so again, we're non-science people, helping you science better because we understand what it means. We can speak the non-science person language. Yes. Okay, so diving right into it. So last week we talked about fractional distillation, right?
Yeah.
Okay. There we go. So fractional distillation, the setup, the only difference in the setup, as you can see here, is basically in the fractionating column, right? Whereas distillation is more simple. It's the container with the mixture, and then you have like water in, water out. So last week we started with this. Now, for some of you like who are struggling with studies, right? Last week I promised that we would reveal to you why is it that you've been struggling so much with learning the science. Like, why does it not make sense? So the funny thing is that last week, because Joe and I were planning for this and we were trying to figure out like how to explain certain things, and then we were designing Particle Planet, our science comic. Basically, it's a science adventure that kind of introduces you to the elements in the form of an adventure like Crocodile Hunter, right? And what happened is that it suddenly hit me when Joe and I were kind of preparing for ImagiNotes that well, the reason that separating techniques exist is because no element exists in its pure form. They're normally in some form of a mixture or something. And so when it hit me, I was like, but you see in the textbook, they don't tell you. They just say, oh, it's supposed to separate stuff. But it's like, okay, but what stuff, right? And they kind of hope that you will get the links between between the thing. Trust me, guys, it was like over 10 years ago. And only now did I realize like, this is why we're learning separating techniques. Because I think like for logical people, like teaching you about like scientific equipment and then moving into like the experiment is logical, which is like separating techniques, but they fail to give you the context for it. So another way to put it is basically it's basically like me telling you that boiling is so this is like the other problem with the textbooks is that they explain things to you like this, right? Boiling is cooking food in hot water. Now, if you had no idea what cooking is, you're gonna be like, what? like okay, like so, But if I tell you, hey Joe, or hey Yvonne, hey, do you know that if you actually do you drink soup? What's your favorite soup? Right? Did you know that they make it through boiling? And then boiling is basically cooking food in hot water, all right, or heating up something in liquid to cook it. Then that makes more sense because we've all had soup before. We all drink soup, or maybe like porridge, right? We eat porridge, or we've had noodle soup. So, so this is that gap that is missing. So we're hoping to fill that gap in ImagiNotes as well. Because in order to do this, we kind of need to dig a little bit and think a little bit more about what we're doing. Okay, so I hope this helps you. Understand that it's not your fault. All right, if you're not getting the whole science thing. All right, because we definitely struggled with it as well, even way back then. Huh, Joe?
Yeah, we are with you there.
Yeah, so many of us, like when the moment we graduate, we're like, thank God, we're just the lucky ones. Joe and I are the lucky ones who decided to do something about it, I guess. So we're working with science facts every day. I thought I left it behind because I went to like performing arts school. Yeah. And Joe went to an art school, digital art.
Yeah, I went to a design
so
school.
yeah. So yeah, so basically that's why. Okay, so I hope this really helps you. If it helps you understand, what's actually going on, feel free to just let us know in the comments, like, yeah, or like, I'm with you. All right, just let us know. All right, we're all in the same boat here. All right, so moving on to fractional distillation.
Yeah.
Okay, so last week I told the story of Ashley, Bernie, and Charlie and they're best of friends, partially because fractional distillation is basically used for what is called, can you see it here? I'll put it here. Miscible
Immiscible
liquids. So
miscellaneous.
to me, miscible sounds like mixable. Yeah. So therefore, that's why we had this story of like, when friendships, when you mix really well, it's very hard to like pull people apart. And the more close you are, the harder it is to break you up, right? So fractional distillation, to me, it's like the fractionating column. Is to break up like strong friendships. All right, and different people.
Say yeah.
All right. Yeah. And different people here, thanks Thomas. Different people here have different different tolerances to pressure and stress and anger and unhappiness. So they will leave each other. Okay, so we were talking about a friendship here between Charlie, Bernie, and Ashley, and they're so tight. They're so tight. But then there's this character called Darla, and she's like really like, ooh, she's super not happy. Okay, she's jealous of their friendship, so she puts it to the test. Right, first she heats it up by spreading rumors and all these things, and then as tensions escalate, she throws more obstacles in their way, so that will be the fractionating column. And then when Ashley finally cannot take it, Ashley's like, you know what, I'm getting out of here, so she goes up first. Okay, so basically the idea behind fractional distillation is that the different liquids inside that mix has got different boiling points. So say Ashley cannot take the stress. Like, she's the one that is like the least like durable. She has the least grit to stress and pressure, so she goes up first, right? And so then when she condensates, then you get liquid. You get liquid Ashley. Yes, you get liquid A, and then after that, when the temperature goes up a bit more, then the next person who can stand a bit more pressure, a bit more heat, all right, which is Bernie, then she's like, I can't do this anymore. Then she leaves the friendship. Okay, so this is how we sort of like our story of how we, try to remember like the steps for fractional distillation, because I think it's a whole lot better than gas A passes into condenser first at A's boiling point. Collect liquid A and stop collecting when temperature rises. Keep heating. Gas B passes into condenser at B's boiling point. Collect B in separate beaker. I definitely did not remember this then. I definitely will not remember it now, and I can't imagine how anyone else would. Okay, I mean, yes, logically it makes sense, but couple that, like pair this up with the fact that many of you are taking like 8 or 9 subjects. I think some of you even take up to 11 subjects in an exam. You're gonna need something a bit more than that. So again, remember, ImagiNotes, you do it for the things that you find difficult to remember, and we're just here to inspire you and give you like ideas as to how you can make your notes and study session just more fun. Because if your notes are fun, you're more likely to look forward to studying and revising, okay? Because as Asian kids, we kind of have to. Yeah, okay? So, yep. So basically, when you do this, it suddenly makes the fractionating column a whole lot easier to remember, okay? So I think you guys sort of get the idea, right, as to this. All right, so how you can do this is you can put Darla here, and then you can use different colors. You know, you can go, you know, you can say,
Yeah, just go crazy with
you
the
can write
colors.
Ashley. Yeah, as long as you know. So Ashley, you know, and Ashley will go first. Then say, you know, this green one represents Bernie, you know. So I'm gonna write Bernie in green. Sorry, it's a bit messy because we did this last week, and I didn't have my colors yet. Then Bernie is like the second one that you collect. All right. So, but with a story, it just makes it a whole lot easier. If I asked you this next week, you probably remember like this, you know. But if this story doesn't work for you, think of another one. Yeah, think of another one. But for us, it kind of helps us remember this definition called miscible liquids. Yeah. When I looked at John, I was like, what's that? And we had to kind of do our own research, yeah, to kind of understand
Yeah,
what
it's
it
true.
is.
It's so
Yeah,
miserable.
miserable miscible liquid. Yeah. So yep, you can. So yeah, I hope you guys get the idea. Okay. Then we're gonna move on
Yes.
to distillation. Yeah, distillation is just simpler. All right. And then I understand also that. Oh yes, one more thing also about the setup that you guys might want to take note of. All right. If you notice filtration, all right, you're using a conical flask, right? So some of you might be wondering, okay, so why? Okay, now the because we don't practice the science of this, all right, I don't know, those of you who actually have a chance to do lab experiments, say I in the chat. Yeah, because I didn't, Joe didn't. I know that from the science industry, a lot of lab technicians in schools are actually very well paid to do. I heard from to do nothing, because you know in government schools here, you know students don't get to use the lab. Okay, so you'll only know this if let's say you actually do it, because if you try to heat this up, all right, under using a Bunsen burner, there's a chance that this will break. All right, so now for distillation, all right, because heat is applied, it's actually better to have a round flask. All right, because then the heat distributes more evenly, so it's less likely to break. Okay, so
It's
you can
more
say that
durable.
this is, yeah, so you can say is that Dala circled them in the story. You can say she circled them, all right, so that you remember that it's a, you know,
She
like she
cornered them.
circled, yeah, she circled them in a net of like, you know, rumors and lies, so many lies. All right, and so and then basically this can also be you know, all the trouble, all right, which creates the
Pressure,
heat. Yeah, all right, so
heat.
yeah, so you sort of associate it as much as you can, all right, with this, all right, or you know, like say heat also could represent anger.
Yeah, heated discussion.
Yeah, so heated discussions, temperatures rise. All right, so that helps you remember also that there's a thermometer. So I really hope that this helps. If anyone's confused, please let us know in the chat. If you want us to tell the story again, let us know. But basically, you can watch it again in the replay. All right, but yeah, we would. So this is how we would tell the story to associate it. We can do another recording with the actual story itself, with this idea of Darla circling them with rumors and lies while we're drawing this. Okay. So if you would like that, let us know in the chat, yeah, whether you would like this, okay? So yeah, we're moving on. So for distillation, it's just really simple. This is basically, okay, so the key idea here is that it's not a miscible liquid, but you're looking at a solvent, separating a solvent from a solute. So something much simpler, yeah, than. But both are miscible liquid.
Yeah.
Is it? Okay, both are miscible. It's just
It
that.
can be. It can be.
Okay. Yeah. So see, we're non-science people, so we're just trying our best right now to help you, sort of like have a grasp on, you know, this sort of thing, as well. And because like, if you learn from a science person, they're gonna teach you in a science way. They're gonna do science speak. All right. So this is us.
Yeah.
Oh, I think I know what's up with my camera now. I've been angling it weirdly, but seems to work. All right. So there we go. Okay, so
It
yeah.
looks fine.
So yeah. So basically distillation, you can say it's for less like tight friendships or, something like that. Yeah, but it's the same thing, all right, just that it just has different functions, all right? This one is just more for different types of like liquids at different boiling points. Yeah, and this one is between a solvent and a solute. So only two things. So what you can do is you can actually say solvent here and mixture. But by the end of it, you have minus the solvent. Okay, so meaning that you only get the solute. So this is something I would do to just help me remember. Yeah, at the end of it, it's just two things. Yeah, whereas fractional distillation, I think they use it for refining oil. Yeah, they also do it to refine. Yeah, they also actually do it. I wouldn't know this if we weren't like researching elements for Particle Planet, but they also do it to actually get argon gas. Yeah, to separate it from like nitrogen and oxygen. Yeah, so they liquefy the air and then they use fractional distillation to separate the gases. Yeah, so yeah, it's very fascinating.
Because argon, nitrogen, and all that, all the gases has different boiling points, right?
Yes, and they're all kind of mixed up in the air right now. Yeah. So yeah, so these are the really cool things that I think they don't really mention in the textbook. Yeah.
No,
so but remember
they don't.
that. Yeah, they don't. But remember that separating techniques exists because no element exists purely. Like your reactive metals are always like
there's a purpose for it.
yeah, it's a chloride or oxide in some sort of igneous rock. Argon, it's like I think less than 1%
Yeah, just
of
imagine.
the air. Yeah, and so how do you get that out of the air? So like we miss the genius of science in the science classes. Yeah, we don't understand it because it's taught to us like boiling is cooking soup in hot water. It's basically taught to us that way. All right, so we hope that this actually helps you sort of remember this better. Okay. Yeah. Okay. And one more thing. Yeah, so for this one, Joe, if you look at the shape of it, like because we talked about last week filtration, so we're just gonna go a bit deeper. Maybe this week, since we have only like 5 minutes left on the clock, next week we'll go into chromatography. Oh, you guys are gonna love what we found about chromatography. We wish we learned it like sort of like in the way that we're gonna share with you next week. But yeah, let's dive further into like how they can actually remember how to set this up, because because for us we believe in doing. Because there's this thing called the cone of learning. When you do something, you retain 90% of what you learn. When you read and you listen to something, it's only 10 to 20%. So essentially, if you're just reading from a book, you're basically working really hard to only remember 10%. But if you do something like ImagiNotes, you actually, or actively take notes and make it fun, and you try and use your imagination, you basically retain between 70% to 90%. And that's why we got on here to help you guys do this, because no one teaches this out there. Yeah, no one teaches this out there. I wish someone had, because my study time would be cut down and I would have more time to play. Yeah, really didn't like studying back then.
Most of the schools, what they would do is actually be directly from the diagram on the textbook then to your notebook. That's it.
Yes, it's up to you how you get this. Yeah, we feel you, because we were like that too. Yeah, if you have a very good teacher, that's really great. Those of you who had a really good teacher whom you enjoyed the lessons, please give them a shout out in the chat. Feel free. Okay, so moving on. Because like good teachers are hard to come by. Like I can only count them on one hand over the years. Yeah. Okay. So Joe, so last week, 2 weeks ago, when we actually did filtration, we actually talked about, how filtration. You just remember triangles. So then it helps you remember
the shape.
So how about this? So we know that we have the round bottom here. That's fractional distillation. We know that if they draw this side by side, fractional distillation has this like fancier fractionating column. But overall, like when we look at the basic shape of this, how would you kind of like zoom out, see the big picture, or see a pattern? You know, what else could they do to sort of remember this? Oh yeah, and this whole idea of like water in and water out, right?
The Liebig condenser.
Yeah, this is the Liebig condenser. Well, actually, I have an idea for this one, actually, now that we're talking about it. How many of you here have watched One Piece? All right, if you have, just let us know in the chat, okay? All right, now this is a bit of a spoiler alert, okay? However, you know, logically, the reason why water goes in here is because then when it goes, because if you put it out then in, it doesn't have a chance to cool down and, cool down the gas that passes through here so it can turn into liquid form. Otherwise, it will just pass through as gas. All right, so the idea is that the water coming in here, if it slowly comes up and goes out, there's a chance of actually making this portion here really, really cool, and therefore condensation has a chance to happen so that this can become liquid, okay? So over here, but water never flows, water always flows downwards, right? Except in One Piece. The water flowed up the mountain, all right? So if I were you guys and I wanted to remember the water flow direction of the Liebig condenser, I would draw, I think, the Going Merry in One Piece over here, the big ship. All right, and you know it's water going uphill. All right, and then if you want, you can also draw. There's a character in One Piece where he's a big fat liar. He's got a big nose. And he always wears a cap. Okay. And then he's got big lips as well. Yeah, his name is Usopp. Yeah, and he lies a lot. He tells big, big lies. So, you know, therefore you get Liebig. And you know the job here is to condense, because that's why the water is flowing upwards. So therefore, Liebig condenser. So I hope this helps you guys remember the Liebig condenser, especially like if you don't know One Piece, you can always find like a different way of like doing it. Joe, if you do you watch One Piece? Do you know this?
No, I don't.
Okay, so from a non-One Piece perspective, how would you remember how water flows in and how it goes up? Like what other story would you tell?
Logical, like a more way of thinking is if you think of gravity, right? It's always pull you down, right? So if you fill in the water from the top, the top part fill, because the water always flows up to the towards the center of the earth. Yeah, so the condensation is not complete. So you will never fill up the whole Liebig condenser if the water always coming in from the top.
Yep. Yeah. So again, you use a way that helps you remember best. Yeah. Like for me, I would probably use Joe's way. Yeah. But if that way doesn't really work for you, you can definitely do something like this as well, especially if you're yeah, you can totally especially if you're a One Piece fan or you like songs, if you can think of something that you can associate this with. Yeah, I just happen to be a One Piece fan, and I found a way that helps me remember better. Okay, so yeah, because you guys are juggling a lot of information. Again, you don't have to do this for everything. We're just here to give you ideas. So if you happen to forget the water flow for the Liebig condenser, go ahead, use this example. Feel free. Yeah, go ahead, turn your notes into something. Okay. Yep. And that's basically it. Yeah. Thank you for sharing, Joe. Yeah, the logical way works too.
No problem.
Yeah. And if that works for you, you don't have to do this. Yeah. Okay. Cool.
Yeah,
Kachu.
I guess.
Yep. Sorry, Joe. Hello.
Yeah. Sorry.
Sorry, I interrupted because you said yes. Cause
No, I didn't say anything.
Did you say that? Oh, okay. My bad. My
How
bad.
gravity works for me is always because it's easier for me to remember. Gravity always pulls you down. So with that concept itself, so if water is coming up, coming from the top part, it will never get filled. Yeah.
Yep. Okay, thank you so much for sharing. Love having you here. Yeah. Thomas says, yes, cool way. Yeah, thank you so much for being here. Yeah, and thank you so much for saying that. We hope that this would really, really help. Yeah. And yeah, so, and again, for this instructions and steps, again, you know, to remember this, and in your drawing, you can number the sections as to where it goes. Okay.
Yeah, you can
And
number
basically,
the
because it says
sections.
here, yeah, yeah, you can actually label the sections. But essentially, if you basically if you speak English and you say it in your own words and it kind of hits the key points in the exams, it works. So ImagiNotes just
Yeah.
helps you with the understanding of it as well, because in order to do this, you need to understand. So, and yes, it does take effort, but it also takes a lot of effort to memorize, retain only 10%, and memorize some more and more. And, like memorize for 3 hours and revise again for another 3 hours. So this essentially cuts down your study time. Yes, there's a lot of effort, but I can promise you that you will remember this way longer while revising a whole lot less. Like you don't have to revise for so long, nor do you have to you don't have to take up too much time revising, nor do you have to do it too frequently either. Yeah, if you do this.
Yeah.
Okay. This is how I learn how to read katakana, hiragana, and hangul. I taught my friends to read hangul using the ImagiNotes method, and they learned it in 2 days, and they could enjoy because we were on a Korean exchange program. They could enjoy themselves after that, because I saw them memorizing, and then they couldn't, because I don't know how many alphabets there are for Korean. I know it's like 20 something. So to do that in the span of a week is actually quite difficult. Yeah. So the way I taught them, they did it in 2 days. Yeah, and they didn't have to revise after that. So we're bringing this to you guys in the form of science. Yes. So yeah, it's 8:34. Thank you guys so much for watching. Yes. Yep. And Joe, thank you so much for sharing. We love having you here.
Subscribe to our channel if you like it.
Yes. And again, if you guys are struggling with anything at all, if you guys are, sorry, there's a lag between me and Joe right now when we're talking, but if you guys have any trouble at all with remembering anything, any topic whatsoever, just throw it at us. We'll figure it out for you. We could even come here. We're not science teachers, but I've often found that the best science and math teachers that I've had were actually non-math inclined and non-science inclined teachers, because they get what they get like the gaps in our understanding, and how come we blank out here, or we're not getting this concept. So yeah, unless your teacher Melinda lah, then teacher Melinda, she sort of understands that and she thinks about that. Yeah. So yes, thank you, Yvonne, being here. We really, really appreciate it. And yeah. 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 Next
See you next week.